This is the example we left at in the previous video. If we drop a piece of balsa wood and a metal pin of the same mass into the water, what will happen? Will both of them float, or will both of them sink? Or one stays afloat and one sinks? Just by intuition, we can say that the wooden block will float and the metal pin will sink. But if they're of the same mass, why does that happen? Shouldn't both float because of the buoyant force? This happens because of the difference in their densities. But what's density? Look at these two parking lots of the same size. One has 3 cars and the other has many cars. Which one is more dense? This one, correct? Yes. Now look at these two forests. Which one is more dense with trees? Clearly, it's this one. So in the same given amount of space, if there are more things, we say that it's denser. Density is simply the measure of how compact the mass in a substance or object is. If we have to go by its scientific definition, we would say that it's mass per unit volume. In short, it tells us how much mass exists in a given volume. The unit of density is kilogram per meter cubed. Mass is in kilograms and volume in meter cubed. Coming back to our example, why did the wood float and the pin sink? The wood floated on water because the density of the wood is lesser than the density of water. Hence, the upthrust of water on the wood is greater than the weight of the wood. Hence, it floated. But the density of a metal pin is more than the density of water. Though it looks tiny, there's more mass per unit volume within it as compared to water. Hence, the upthrust of water on the pin is less than the weight of the pin. So what can we conclude? If the density of an object is lesser than the density of the liquid, then it will float. And if the density of an object is more than the density of the liquid, then it will sink.
So in our last discussion, we discussed about what is density. So now we will try some problems. First, a piece of granite rock has a mass of 15.5 grams and a volume of 6.01 cubic centimeter. What is its density? So first, we know that density is equals to mass over volume. In a given problem, we know that the mass is 15.5 grams and the volume is 6.01 cubic centimeter. Therefore, 15.5 divided by 6.01 is equals to 2.58 grams per cubic centimeter. So that will be your final answer. So we will proceed to the next problem. Gold has a density of 19.3 grams per cubic centimeter. If you have a gold bar with a volume of 44.9 cubic centimeter, what is its mass? So in this problem, we're going to find the mass of the gold. The given formula is D. Density is equals to mass over volume. Since mass is what we need to find, we need to simplify first the equation. Cross multiply, so we will cross multiply, so we will have mass equals to density times volume. Next, we are now ready to input all the given density and the volume. The density is 19.8 grams per centimeter and the volume is 44.9. Wala nang ibasa ka ng tama na. Next is mass. So 9.3 grams per cubic centimeter times 44.9 cubic centimeter grams. The problem is isopropyl alcohol is a liquid with a density of 0.785 grams per cubic centimeter. How much volume would be taken up by 50 grams of isopropyl alcohol? So in this problem, you are going to find the density and the volume of the isopropyl alcohol. So the formula of this is density equals to mass over volume. Again, cross multiply, you will get volume times density equals to mass. Then divide both sides by the density. So you will get the volume is equal to mass over the density. So in the given problem, the mass is 50 grams and the density is 0.785 grams per cubic centimeter. So the volume will be 63.69 cancel the grams cubic centimeter. That will be all. Thank you.
Say you're holding a slightly heavy object in your hand. Now, if you try to hold that object within a container full of water, you'll notice that it feels lighter. It doesn't feel heavy at all. What happens when you put an empty glass into a container of water? Of course, the glass fills up with water. So you're holding the glass of water inside the water which is in the container. And now, when you try to take the glass outside the water, what do you notice? Yes, the glass feels heavier when it's outside the fluid. And the same glass full of water felt light when it was placed inside the fluid. And that brings us to the concept of buoyancy. What happens when an object is placed inside a fluid? As we'd seen in the previous video, the fluid pressure increases with depth. Now, because the pressure increases as we go deeper, the force exerted upward due to the pressure will be more than the pressure exerted downwards due to the pressure. So the force exerted on the bottom of the object due to pressure will be more than the force exerted on the top. So this net upward force exerted on objects submerged in fluids is called the buoyant force. You can test this with a tightly closed empty plastic bottle and a container of water. If you drop the bottle on the fluid, you will see that it will float. That's because the fluid is applying an upward force on the bottle. Now hold the bottle and push it inside the fluid. You'd notice that the bottle is also exerting an upward force on your hand. If you leave the bottle, you'll see that the bottle will come up to the surface on its own. I think you can guess why. Now push the bottle deeper inside the fluid. You will feel more force against your hand. And when you release the bottle, it'll rush back to the surface. It'll come up faster than it came up in the previous case. The upward force increases as it's pushed deeper into the fluid. And that's because the pressure also increases as we go deeper into the fluid. This upward force exerted by the water on the bottle is known as upthrust or the buoyant force.
So what is up, guys? So there will be a problem about buoyant force, which is a standard basketball mass of 624 grams and 24.3 centimeters in diameter is held fully underwater. To calculate buoyant force and weight when released, does the ball sink to the bottom or float to the surface? If it floats, what percentage of it sticking out of the water? If it sinks, what is the normal force Fn when it sits on the bottom of the pool? First is to know the given of the problem. So the given of the problem, it is there will be a basketball, then its mass is 624 grams or 0.624 kilograms. Next, it has a diameter of 24.3 centimeters or 0.243 meters. We know that the diameter is half of the radius, right? So, okay, we will visualize the problem. So, underwater, there will be a ball. So, first is calculate the buoyant force. buoyant force is equals to the density times the volume and the gravity. We know that the density of the water is 1,000 kilogram per meter cube. Density of the water. We know that the volume of a sphere is 4/3 pi r cube. So the only thing is missing here is radius. We know that the volume is 4/3 pi. Substitute r to d/2, which is the diameter, because that is the only thing we have right here, cube. If you substitute it, the diameter is 0.243 meters. If you substitute it here, we will come up with an answer of 0.00751 meter cube. So this will be our volume. Next is the gravity. We know that the gravity is standard of 9.81 meters per second squared. So we have all the values for buoyant force, so we need to substitute it. So to calculate the buoyant force, we have our density of 1,000 kilogram meter cube. Next is the volume of 0.00751 meter cube, and lastly the gravity of 9.81 meters per second squared. So if you multiply it all, you will come up with an answer of 74 newtons. Why newtons? Because meter cube will be cancelled out and kilogram meters per second squared is a newton. So buoyant force is 74 newtons. So next is there will be a water, right? There will be a ball. So we know that there is a buoyant force acting upward and a gravitational force acting downward. We know that the buoyant force is 74 Newton. Next is we will find out which is greater, the buoyant force or the gravitational force. To find the gravitational force, we have a formula of mass times the gravity. We know that the mass is 0.624 kilogram times the 9.81 standard gravity meters squared. So we will come up with an answer of 6.1 Newton. This will be the gravitational force. As you notice, buoyant force is greater than the gravitational force. Therefore, the ball will really go out upward. Next is, question is what percentage of it sticking out of the water? So to get the percentage, we need to find the density of the ball in the water and outside of the water. So therefore, we need to find that density is mass over volume. Right? We know that the mass is 0.624 kilograms and the volume is 0.00751 meter cube. So the density would be 83 kilogram per meter cube. If you were going to compare it, density of the ball, if you're going to compare it to the density of the water, which is 1,000 kilogram per meter cube. So if you compare it, the density of the water is really bigger than the density of the ball. Therefore, we can conclude that there are only 8.3% of the ball will remain on the water, while the other one is 91.7%. So this will conclude that in a ball, in the surface of water, the density of the ball, which is 8.3% only, is on the water, while the 91.7% of the ball is outside the water.
She looking at me like she wanna freak, I'm on it. I swim in the sea like we on the beach, she love it. I treat her right, fulfilling desires in life.